Okay, this is the table of contents. And the first introduction. Um, in open cut earthwork, you can use GNSS, so you can get a high precision for automation of construction. However, underground spaces, such as mountain tunnels, you cannot use GNSS. So it is very difficult to obtain the precision in the construction work. There are a number of works for mountain tunnels. Among them, there is invert construction. Invert construction is after, the uppermost figure is the face of a typical mountain tunnel. After the excavation, there is a pressure from below. So you need to withstand the pressure. Then you excavate like a concave bottom shape. And then you cast concrete in the invert. This is called the invert construction. And this requires both precise excavation shape and the ability to move autonomously during operations. This is a picture of a typical mountain tunnel. And it shows the after invert excavation. So if you excessively excavate the invert, then the excavation volume increases, and also at the same time, the concrete that will be cast increases, which is very costly bad. So precision is necessary. Now, digital twins can provide multiple types of work. In mountain tunnel construction, multiple types of works typically alternate while working in confined spaces, narrow spaces. Implementing autonomous operation requires real-time, accurate awareness of its spatial relationships and operational status relative to other works. So digital twins can offer the advantage of enabling remote personnel to intuitively grasp the entire site. There are a number of safety risks in mountain tunnels, and there are also health risks as well. So reducing or eliminating personnel inside the tunnel is highly desirable. And it is also desirable to enable remote management for personnel. So the objective of this research was in non-GNSS environments, to propose a method to automate invert excavation works in mountain tunnels and to utilize digital twins for the automated and unmanned invert excavation operation by safe remote monitoring. There are a number of research for mountain tunnels and mountain tunnel automation. However, no studies have been found that have conducted automated invert excavation or mountain tunnels, and they employed digital twins for unmanned safe construction and monitoring in non-GNSS environment. So the proposed method consists of the following two approaches. The first one is a technique for high-precision automated invert excavation in mountain tunnels under non-GNSS conditions. And second is a technique for managing automated operations by remotely monitoring site conditions via digital twin. So this picture shows the backhoe machine that we developed. This machine has a 2D LiDAR and hydraulic controller and 4 inclinometers and 4 steering angle meters. So it can, this backhoe can proceed from the tunnel entrance to the mountain inside, mountain tunnel inside by a 2D LiDAR. And then at the Invert construction site, they encounter 2 big cylinders. Okay. And then the very accurate position can be fixed by these 2 cylinders by scanning the cylinders. Okay. As for the digital twin, the above figure shows the system architecture, and it can obtain the current status of the construction site, and then the remotely using VR, the engineers can monitor the construction site visually. And every construction worker wears Bluetooth low energy BLE beacons, and also every construction machinery has BLE as well, so that the location of the construction workers and the machinery can be converted to the digital twin. So in the digital twin, the construction engineers remotely oversees the construction site, and there are 2 areas, manned area and unmanned area. In the unmanned area, autonomous automated backhoe operates the invert construction, invert excavation. At the manned area, the reinforcing work and other construction work are underway. So remotely, by the fixed 3D LiDARs on the walls of the tunnels, you can measure the precise ground work and also the current status. So, okay. We employed this proposed technique to real construction work in Kyushu Island of Japan. Okay, so as for the accuracy of errors of invert excavation, it was good, but it was not as good as the precision of 5 centimeters. It is due to the vibration, hard vibration of the backhoe, especially vertically. Okay, I will skip that. And also, we interviewed the engineers who use the digital twin management system, and they said that the digital twin system was very good for managing the manned and the unmanned area safely. and there are more positive comments as well. Okay, so this is the conclusion, but I have to finish. So here in this research, we proposed an autonomous, automatic invert construction backhoe machine, and also the digital twin management system for the tunnel construction. Okay, thank you.
Okay.